We're going to treat it the same way as the translations. Like we'll say in general what they are, but then we'll give you some rules for moving points around the coordinate plane. So it's going to be similar to the translation. So you're going to have points that you're starting with. They're going to ask you where the points end up. And for both of those, you're going to see there's going to be patterns we talk about, but there's also going to be ones that I go through that do not fall under the realm of those patterns. And we'll talk about how to move things. But for rotations right now, you're being limited to very specific angle measures. And even reflections, we're kind of limiting the ones that you're going to be working with on those as well, just to kind of simplify what you're doing right now. 40s, I don't know. Okay, so all a rotation is, and we talked about it yesterday when we went through the initial transformation, just showing what they look like. All right, so rotations are you just turning an object. It's always going to be classified by a specific number of degrees. So it could be any number of degrees you want between 0 and 360. Because if you moved it 0, you're not moving it at all. And if you rotate something 360 degrees, it's just going to go back to the original shape. So anywhere between 0 and 360 degrees, you can rotate a specific object to make it go somewhere else. When you rotate objects, it's always going to be around a point. Because basically what you're doing, as I mentioned yesterday, is that point's going to serve as like the center of a circle. But the distance from that center to each single point that you're rotating counts as like a radius. And then that point just travels along the circle in that specific radius that you're working with. All right, so it's going to change the, you can say location, could be orientation of it. Something that means that you're turning it so that it's not facing the same way and it's not necessarily flipped directly opposite, because that would be the reflections. But what you end up with, so your image, what you end up with and what you start with, your pre-image, are going to be the same shape. They're going to be the same size because they're isometries. It's a rigid motion. Remember, rigid means that you're not changing the size of the shape you're working with. And like I said, each point on your rotation is moving around a specific circle. So like if I looked at this point R, which again this would be your pre-image, right, because there's no little prime marks with it. If I was rotating it around this point, I'm saying this is like the center of a circle. That's a radius of a circle. And if I draw like a little arc between those two, that is a part of the circle, because this is a radius. This length is going to be the same side. It's essentially a radius of a circle. If I went all the way around, that's a horrible circle, but it would make a circle like that even though it's bowed out over there. Okay? Yeah, you know. That is a perfect circle in my mind. It works fine. Okay, now other things that you're going to note up here. You've got directions here that tell you which way to go. Right? Clockwise would be that way. That's clockwise. Counterclockwise, and those are the abbreviations for it, would be that direction. They're also going to give you, again, degree measures. Like this one here is 60 degrees. That one over there is 40. Meaning that this angle right here would come from those two put together. So that would be like a 40-degree angle in that case. And the other one over here, which I can't draw on, but like this angle right here would be 60, and so would that. And you're always going to be given an angle measure and a direction to go. Also, they could do this. This is considered a rotation. This is in the negative direction. So if you see a negative angle measure, it means this direction. This is a positive direction for like a rotation. And I'll show you how maybe this will work on your graph paper. All right, so you guys, for at least the time being with this, because this is basic transformations, We're only focusing on those three angle measures. So 90 degrees, 180 degrees, and 270 degrees. Okay? Now, one of the big things is when we do this, I'm going to kind of use slope to figure out where the points are going to go. Keeping in mind things like if it's 90 degrees, this is a right angle, which means that I'm going to essentially be creating perpendicular lines. And if I look at slopes for perpendicular lines, they're opposite reciprocal. So I'm going to kind of use that principle to figure out where these points should go on the rotation over there. All right, so they got a point that's plotted, the 3, 4. All right. Here, and you look here, they've got it. See, this one is negative 90 because it's going clockwise. That one's a positive 90 because it's got it going counterclockwise. Okay. All right, so I think it says here, does it say where it's going around?
3/4.
No. I mean, do they give you directions? It should be, all these should be rotating around this point right here. It should say somewhere in there that we're going to move this, we're going to rotate this point around the origin.
Nope.
Well, you are. Okay? So this point here, 3, 4. All right, so if I'm saying, and if they say the origin, guys, that's the point that O, they might use the letter O for it, but it said 0, 0. When you do rotations, like I said, essentially what you're doing is you're creating a little circle, right? This is like the radius of a circle. So if I rotate this anywhere from this point on, it's got to follow, it's got to follow somewhere along that specific circle. Okay? So if I rotate it, I don't know, whatever, 120 degrees, it'll end up down here somewhere. If I do it 200 degrees, it'll end up over here somewhere, so on. Now, you guys aren't going to have to sit there. You could probably go in and actually take like a compass and draw on a circle. You can figure out where it should go, or at least you can see the track it should follow. But since we're being very specific here, and again, like we're going 90 degrees, we're essentially going to create a perpendicular line, but the lines that are going to be perpendicular are going to be a radius, meaning that the length of this line here has to stay the same no matter where I move it. So what I'm going to use is, like I said, I'll use the kind of idea that I'm working with slope, but really I'm working with these two sides of the triangle. Okay, so if I go from here out to this point here to see how far horizontal that is, that should be a length of 3, that should be 4. Okay, so wherever I put my next point, the two sides of that right triangle better be 3 and 4. Okay, now I've got to move it, I've got to move it this direction, right? Because I'm going counterclockwise 90 degrees. Okay? So, write these like this. There's 4, there's 3, there's 4. Okay? So, if I create a perpendicular line to this one in this direction, it would be something like that, maybe. Correct?
Yeah.
They look like they're about 90 degrees. Yes? No?
Yeah.
Okay. For me to make certain I'm doing it that way, all I'm going to do is if I have the understanding that this thing has to rotate here, and I need my two sides to be 3 and 4, I'm going to use the idea that if I'm doing a perpendicular line, these have to flip positions. So my 3 is now going to be on the vertical. So 1, 2, 3. And then I'm going to go out 1, 2, 3, 4. This is where it's going to end up. I'll make that dashed. So what do they call this? Point A, there's my A prime. Because this is definitely a right angle. Because the slope of this line is the opposite reciprocal of the slope of that line, so I know it's perpendicular to it. Like the slope of this one here is 4 over 3. The slope of this line right here is negative 3 over 4. So that means I definitely know they're perpendicular. And also, since these two sides are 3 and 4, that means that this length here is the same as that length there, because both of those right triangles, if I do Pythagorean theorem, will give me a length of 5 there. So as long as this has the same length as this one does, which it does, then I know I'm creating a rotation the correct way. All right? Yeah, what were you guys going to ask? Just one of you guys. Because I'm doing this one. Oh, I went the wrong way. Sorry, guys.
Oh, man.
I kind of forgot we were going that way. I've said it, but I forgot. All right, so I'm counting, but I'm still counting. Was that 3 and 4? I'm still counting 1, 2, 3, 4. There. A, There's my A prime. 3, 4, 3, 4. Now, like, the whole point of doing this right now is just to figure out a pattern. There's going to be a pattern to these. It's not like you're going to have to go on your graph paper and count these out every single time, because it's kind of a pain. All right? But the patterns we're doing here, since these are all around the origin, are only going to fit for these around the origin, as you see at the bottom. Okay, so I'll fill that in. This point here should be, what am I at? Negative 4, 3. Okay, so you start, for this one here, you started at 3, 4, and you went to there. All right? And if I do the clockwise one, where was it? It was right there. So that clockwise one took me to 4, negative 3. That was that first one I put up there. So this one was 3. Okay? Now, like, when you go through the chart, guys, you should be able to come up with some kind of specific pattern for it. If you look, there's only a single difference between these right here, right? It's where what thing is changing sign. And that's going to hold true when I get down to maybe the 270. But if I did another 90-degree one, the same thing would be true. Like if I did the point, if I started with the point 1, 2. And I did like a 90-degree rotation, either clockwise or counterclockwise, it would be, if I did it counterclockwise, what do you think it would be if it followed this same pattern? So like my counterclockwise here went from 3, 4 to negative 4, 3. If I start at 1, 2, where do you think it might go? Yeah. Okay? And then I could do the same thing there. If I did it clockwise, it would go to 2, negative 1. All right, so there is going to be a pattern that we'll write out. All right, so the 180, all right, if I do 180, if you notice here, it doesn't matter which direction I go, because if I go 180 degrees, that's directly opposite where you're at, meaning that it's got to be over here. So if I go counterclockwise or clockwise, I'm going to end up at the same point. Okay? But I'm still going to use the idea that this point from the origin where I started was 4 up and 3 over to the right. So I'm going to go the opposite directions. Now I'm not going to switch the signs because I want it to be directly opposite. So instead of going 4 up to get to that point, I'm going to go 4 down. Okay, so I'll go down 4, and then I'll go to the left 3 instead of to the right. That would be 180 degrees away, which that point is negative 3, negative 4. And guess what? If I went the other direction, it's still going to be negative 3, negative 4. Okay? So again, if you look at where you started, which still is the 3, 4, and where you ended up, the way that this point relates to this one applies to all the 180 degrees. So again, if I started at point 1, 2, and I did it 180 degrees, where do you think I might end up? Negative 1, negative 2. Okay, so you're just changing the signs of them. I will tell you this one here, if you go, let me erase this again. If I go 270 degrees counterclockwise, okay, 270 degrees, the way you would get there is you would go 90, another 90, and then another 90. 270 degrees will take you all the way around to there, so that's 270. The shorter way to get there is to go that direction. How many degrees do you think that is? These two are going to be the same. These two are going to be the same. 270 degrees counterclockwise is the same as 90 degrees counterclockwise. Or I mean clockwise, sorry. Okay? And 270 degrees clockwise, this is the same as 90 degrees counterclockwise. 100% of the time. Okay? It's because the circle's 360 degrees. So if you take 90 out, you're left with 270. If you take 270 out, you're left with 90. So this here would be 4, negative 3. Negative 4, 3. The thing that was right above it, which you just had filled in. Okay? Like let's say we looked at the top one for the 90-degree rotation. For that 90-degree rotation, did it start at 4, 3 or 3, 4? 3, 4? Okay, so you started at 3, 4, and then when you did the 90-degree counterclockwise, that took you to negative 4, 3, correct? Right, that's what it said in the chart. Yes? Okay. The way that you're going to do this, and the way that the rule applies, is that for all 90-degree rotations and the 270, because remember that this one and this one are the same, like these two are the same, and these two are the same. Okay? For all these 90-degree rotations, whatever numbers are here, you're always going to flip. Okay? Meaning that started with like 4, 3. So what happens is, on all of these, you're going to reverse the positions of whatever you start with. Okay? The only difference between them is which one you're changing the sign of. Meaning that for this counterclockwise one where we started at 3, 4 and went to negative 4, 3, the numbers flipped. And then after they flipped, that first one changed the sign. Right? This was correct? This is what you have, yes? Okay. So that means that this one here, once I flip them, I'm going to change the sign of the first one. And since these two correspond, I'm going to change the sign there. For the clockwise one, right? The clockwise one went 4, 3, and you ended up at 4, negative 3. So again, the original numbers changed positions, and then after they changed positions, you change the sign of the second value. So that and that. Now it reads odd, and there's a tendency to get mixed up in your head, things like changing, you'll remember like negative y, and you'll flip them and then change the new y value. Okay? It's not saying that, it's saying flip them first, and then this is telling you which one to change the sign of. Okay? And then for this one right here, all that happened was you took the original and flipped the signs. And again, it didn't matter which direction you went because 180 is always going to take you to the same spot, whether you go clockwise or counterclockwise. All right? If you want to answer this, I already told you this one it's going to end up back at the original position because 360 is a complete circle. It's about rotate something in a complete circle. It's going to end up right back where it started. Okay, and then with this one right here, the center of rotation is not the origin. I'll do like a problem like that. But it's just a matter of you have to sit there and we're going to have to see how far away each point is with those little triangles. It's going to be a lot of drawing. Is that 1, 2, 3, 4, 5? That point there is at 2, 5. This point here, 2, 3, 4, 5. This is 6, 0 for D. B is at 2, negative 1, and A is at negative 2, 2. Okay? So now, and I'm doing this around the origin. So my origin's right there. I'm going clockwise, so it's going that direction. Okay? Now, I'm going to do this with the patterns, the shortcuts that were there, that last table you filled in. If you want to do it with like the triangles, you can. Like keeping in mind that like from A to the origin would be 2 this direction and then 2 over there. So your next one has to be also that length of sides for the legs of the right triangle. But the way I'm going to write this out is I'm going to do each point separately. So A was at negative 2, 2. All right, so I'm writing down my pre-image points is what I'm doing there. B was 2, negative 1. C was 2, 5. D was 6, 0. Okay, now, when you do the 90 degrees or the 270 degree rotations about the origin, like around the origin, so origin is your center point, I would suggest writing these out because there are shortcuts to it, the patterns that were in that chart, instead of necessarily graphing it. And when you write your image points, the first thing I would do is take the coordinates that I started with and reverse their positions. Because 90 degrees or 270, you have to take your original one and flip the numbers. So my first step would be changing them so they look like this. Okay? Now I'm not done. This is just a step. So my first step, if I'm doing the shortcut, is flip the X and Y. I think your second step is change the correct sign. So I'll say appropriate sign. Okay, meaning that if you look at the chart, right, the chart should have had X. Chart should have said that, correct? Like if you look at the chart for 90 degrees clockwise, you should have your pre-image point goes to that for an image. Yes? Yes or no? Look at the chart. Just tell me yes or no.
Yes.
Yeah, okay. So this is telling me that after I flip it, I'm going to take my second, whatever's in the second position, after I flip it, I'm going to change the sign of that. So that means that I come up to this point here. I flipped it. I'm looking at -2. This is the one I got to change, so I'm going to change that to a +2. This is already flipped. I'm going to take that +2, change it to a negative, change that to a negative, that to a negative. Like that's all the negative is saying over there is take whatever, after you flip the X and Y, look at the second number, whatever that second number is, you change the sign. If I was doing this counterclockwise, I would have started the same way, but on the second step, I would have changed the first sign instead of the second. So if I graph this out, which there's no way I'm going to have room there because it cuts it off, but like A would be at 2, 2. That's where my A prime would be. Which makes sense because, again, it's got the same length. It's got the same two legs there going back to the origin. Right? B would be at -1, -2. So B would be over here, which again makes sense because it's going that direction. Okay? So again, the way the rule works is the first step is to flip them, then change whichever one you're supposed to change. Kind of okay right now? The rotation one, the shortcut way, kind of trips people up usually. All right, I'm going to make that graph disappear. I'll leave the numbers up there if you need them, but I'm going to make them disappear for a second. So I'm going to go to this. And we're spending more time on this than reflections. Reflections are a little bit easier than rotations. Okay, let's just say, for instance, I'm not going to graph this out first. I just want to do another point, like rotating it in one direction. Okay? So let's say I start with the point K and it's at, I don't know, give me a number.
3, 4.
So -3, and give me something else. 12. We'll do 4 next. All right, so let's say I have that point there. And I want you to take this point, and I'm going to say I want you to rotate. Okay, we'll do 90 degrees. We'll do counterclockwise since that last one was clockwise. Around the origin. Okay, so again, what I would say is look at the chart, either graph it out and do the thing with the triangles, okay, or go back to the chart because it's rotated around the origin. So as long as it's around the origin, I can use the shortcut things that were in the chart and look at the pattern that was there. So the pattern should have said XY goes to -YX, which again means my first step is I'm going to flip the X and Y. So if it's a 90-degree rotation or a 270-degree rotation around the origin, my image point, my first step is flip it, then look at the rule, and whichever one has the negative, whichever position has the negative. Don't pay attention to the X and Y that are in there, because that's where people screw up. They see -Y and they go here and they change the Y coordinate. The position of the positive and negative is what matters. So the position for this one is the first one. So I'm going to go to my first number, change the sign of that. All right, we'll do this one here. B, C. All right, so this point here is 3, 2. That point is 7, 4. Okay, so with those 2 points there, and I'm just doing a single point, we're going to rotate C. We'll do it 90 degrees. You want to go clockwise or counterclockwise? Circle. Clockwise around B. Okay, meaning like, okay, now point B that I have up there is the center of the circle that C has to travel around. If I connect the two, right, that's a radius. So that means that this length is not going to change no matter where you rotate it. It's just like putting the compass there and rotating the compass around. Okay, now, so 90 degrees and we went clockwise. So again, I'm making a perpendicular line. And the way you're doing this you have to do with the slope. You're not going to be able to like necessarily flip things around. Okay? You could flip things around, but it takes a little bit of altering the numbers, like making this a false origin and stuff, but I'm not going to get into that shortcut. If you're really curious about that, I guess I could show some people, but I'm not going to show it. So the numbers I'm going to be concerned with are going to be this one here, which how long is that one? How long is this right here? 4, and this one right here, which is what? 2. So again, I'm looking at like the slope, right? Because I want to make a perpendicular line because it's 90 degrees. Slope of that one is 2 over 4. Okay, not reducing it down because I need that actual length to stay the same. So that means when I do my flip part, when I do the rotation, I'm going to be using the numbers -4 and 2. So that means that I'm going to be doing 2 in the direction to the right, and I'm going to be going 4 down. So if I go 4 down from here, 2, 3, 4, and then 2 to the right, that's where my C prime is going to end up. Okay? So that one should match up to that one unless I just miscounted wrong there. All right, so that would go to, is that 5, -2? So if you're doing any kind of rotation not around the origin, you have to sit there and count off because these lengths here have to be the same. If these aren't the same, then your triangle, this length here, won't be equal. So the idea is if you have the two sides of the right triangle the same, the length is the same because of Pythagorean theorem. Okay, and then they're also the flips of each other, so I know that they're perpendicular because the slopes are opposite reciprocals. Can we do another one like that? You will have to do these. Do I need to do another one? Yeah. All right. Give me some other numbers.
7.
No, we already did 7. Give me some negatives, positives. I don't care.
9.
Wait, negative what?
2.
Wait, who said something back there? 5. We'll do -9, 5. That's fine. Oh crap! I gotta count 1, 2, 9, 5. We'll call that point. What have we used it? M. With that M. All right. Give me another 2 numbers. 6. That won't be good. Give me another negative number to start. We did 4. 3. I like 3. And then we'll do 8. I heard 8, so we'll do positive 8. 3, 8. And that'll be point and L? Sure, L, fine. Okay? All right, and we'll do, so I'll do rotating, we'll rotate point M. We'll do 90 degrees counterclockwise around L. Okay? All right, so that means this is the center, this is the point that's rotating. So we're going counterclockwise, so it's got to kind of travel that direction. All right? That would be much tighter, but oh well. So now again, this is the distance I have to preserve. So I need to count off my 2 sides there. So I know like to get to from L to M, I got to go down. How many is that? 2 or 3? 3, right? So if I count, it's 1, 2, 3. Then I go this direction, 1, 2, 3, 4, 5, 6. So wherever I put my rotated point, I have to have the 2 sides being 3 and 6. Okay? All right. So now when I do it, instead of counting, actually, you know what? It would be easier if I draw it like this. There's 6, there's 3, because otherwise it's going to get a mess in there. Okay? So now that they're going to flip-flop each other. So they're going to reverse kind of positions there. So I need to go 3 in the horizontal direction and 6 up and down. So I'm going to go from the center point always. So I'm going to do this one first just to give myself room. 1, 2, 3, 4, 5, 6. So there would be 6. Okay? So that'd be down. And now to give it like a slope that's a different sign, instead of going to the left, I got to go to the right. But now I got to go 3, because 3 was my vertical here. It's got to switch to my horizontal there. 3. That would be 90 degrees. This point here would be the image of it.